Hi, this is Omer Uzeran, and this video is for data698 for the research project. This is for submission of the project proposal. And my project proposal has a different, my topic is basically hospital diabetic cases readmission. And for this proposal, I do have a couple components. And the first one is introduction. Second one is summary of three key journal papers. And the third one is problem formulation. And fourth one is methodology. And fifth one actually assumption. And finally references, three key journal papers. The first, in the introduction, I talk about what the hospital readmission is basically, and I talk about what the diabetics means, and also the last slide I talk about what is the main purpose of this project. So basically, the main purpose of this project is to find out how modern modeling via machine learning techniques can help us to predict the 30 days hospital readmission of diabetic patients who are at the risk of getting readmitted, and to learn the relation among the features and their importance in determine whether the patient will be admitted or not. So basically our the classification problem, this is a classification problem, and a classification problem, our target is basically presented as a 1 and 0. 1 is basically referring to readmission, 0 is not readmitted after a discharge. So next component is basically talks about the summary about the three key journal papers. The first journal actually talks about how the machine learning or the deep neural network models can help us understand readmissions. The second article actually talks about that, talk about the organization that are called hospital readmission reduction problem, and then what are the diagnostic they find out that what might cause the readmission. So basically, they say that the first one is basically AMI, and the second one is a chronic pulmonary disease, and third one is a heart failure. And lastly, I talk about what is United States has 9.3% population diabetics and 28% which are diagnostic. And in the problem formulation, basically I do have two hypotheses to find out the answer for those questions. The first one is, can we avoid the 30-day readmission by estimating how much of impact the feature had on the readmission of diabetics? The second one is, which of the various prediction models in machine learning would be able to predict whether the patient will be readmitted to hospital or not with a good accuracy. So basically, we're going to try a bunch of, I'm going to try a bunch of different machine learning models and then find out which model explains readmission the best. And the methodology basically has a different components inside. The first one is obviously is loading the data. So my data is coming from the UCI machine learning repository. And then I do have a link here. I put the link here. So basically, it's going to be one source. I will get the from the machine learning repository the data. The second one, what I will do is basically I will investigate the many variables in data to understand the readmission. So investigation basically will have shown the readmission and showing the readmission via race, and then readmission with the gender and gender versus readmission, and then looking at the correlations and correlation between input and readmission, and then looking at the patient discharge and time spent in hospital. It's going to be a lot of EDA analysis and showing a lot of plots in that component. And the third one is basically data mining. Once I do the EDA, next component is going to be where I'm going to use a different data mining concepts. So the first one is basically I'm going to use a feature encoding to convert the string features to categorical. And then second one, feature transforming to use a different transformation function to create new features in data. And third one, in imputation, basically, I'm going to fill that imputation with the feature imputation techniques and then feature filtering. So basically, I'm going to filter the features based on looking at the missing percentage or looking at the weak prediction indicators. And then the fourth one is going to be building a model. So we're going to be using different machine learning models in logistic regression, KNN, support vector machines, extra trees, and random forest adaptive boosting. And the final, I'm gonna have the model evaluation where I'm gonna look at the performance of these machine learning models. So when I look at the different metrics to compare the models, I will be looking at the accuracy rate, advanced score, precision score, and the recall. And finally, I will look at the accuracy that gives them a higher, and also it makes sense to get a better F1 precision and recall score. And I do have only one exception in this project that it's enough getting enough historical exercise data can be collected from University of California Irvine machine learning repository that I assume that I will have enough data to explain the rate missions. And the final, I do have three article links here that I mentioned there earlier. It can be reached out here. Um, um, Thank you so much.